Hi, my name is Anshu and welcome to my channel Bottleneck. This is a Scala Design pattern series. In this series, we are going to implement design patterns applicable to Scala. In the previous video, we had learned about abstract factory design pattern, the structure of the abstract factory design pattern. Now we are going to implement the same. For implementation, I have divided this video into two parts. In part 1, we are going to implement a project that we are going to use in due course of time to implement and execute multiple design patterns, and in part 2 we are going to implement the actual factory design pattern with the structure as we mentioned in the part 1 video, in the first video. Now if you missed the previous video, I will provide the link in the description. So let's begin. This project I have created using SBT. The Scala version is 2.12.18. This is Scala test and this is what I am using to pass the command line arguments. Now how we are going to run this project is we will pass app -name and the name of the app that we want to run. That app name will map back to the class that we want to run, and this is how a standard industry practice is. So let's create a package. So it's com.anshu and then we will be creating Scala design pattern. In this we will need main for all, where we will hold our main, and also we will need a class to run our abstract factory design pattern. So let's create a package for it. Abstract factory design, and let's create a class abstract factory design. Now let's get back to our main. So before we start implementing our main, we need something to pass our command line argument. So let's create a command line parser. It is going to be a Scala class which will, okay, let's fix the name. Alright, so it will take an argument args, which is array of string, and this args it is going to get from the main. Now let's create a companion object. Let's define an apply method. So apply method will take an array of string and it will return a command line parser. Now we also need a data type to hold our application argument, because that is what we are going to pass. So let's create a case class application arguments. Here let's create a value called app name, give it a type as option of string. In real-time scenario we used to have multiple values, but for sake of this video we need only one, so we will create only one. Let's import the companion object and everything here. Now it's time to implement the parser. Nice. So we are using option parser, so it's going to be new option parser, and here we are going to define the data type of what the command line, so it is going to be application arguments. Next we are going to define the type of the app, so it is going to be Scala design pattern. Now once we have done this, now we have to define the values that we are going to pass. So first thing is it is going to be option of string. How we are going to take it, either it is going to be a or it is going to be app-name, and there is an action. Action is a partial function where we are going to pass the value and the object of the application argument. So this is how it is going to return. So it is going to be options dot copy, and we have the value app name as sum of value. Now we also need to define a text in case if user wants to know what I need to pass. So it is going to be specify the application name. So we are set here. Now let's go to our main and implement the main. Let's create a main for all. Main for all. As we are going to extend it, so let's make it a trait. It is going to have an abstract method. First, let's import the command line parser or command line parser. Now def run. It will take app args, which will be of type application argument, which will return a unit. Let's implement an companion object which will have the implementation of main. Same thing, we need the command line parser.application argument, so let's import it here as well. Now let's write our main. So whatever we do inside our main now. So it is going to be array of string, and this is going to return a unit. Now inside this, let's pass the command line argument, and we pass the args. Now where let's create a parser, parse command line. Now on top of parser, we need to extract our app name. So we will parse. What we are going to pass here is first element is the args, the array of string, the command line argument, and second element would be the value as an object. Now here we are getting a value mapped with the args to application argument. Now we need to compare whether which app we need to run. So let's implement a pattern match here. Okay, so it is going to be case of some options which returns an option. Okay, so what is type of option? Type of option is basically an application argument. So till now we had passed it and we have extracted the application argument. Next thing is we need to do something with this. So what we should do? So we need to get an app name or a app class from this to run, to instantiate basically. So what we will do is we will do an app name dot map. So first thing is when we do app name, it is going to be an option of string. So we are getting a string now. Now we need to map this back to the actual class that we have. So it is going to be app, and this is just going to be a string. Here it was option and here it is just a string. Now how we can get a value, convert a value from string to a class? So for that, let's implement a map. Let's create a object for it to hold the map for all the design patterns. I created an object here, and inside this let's define a app map which will have the map. A mapping would be the value. So how should we call it's abstract factory design? Let's call it AFD, and it's going to be class of, and which class it is going to be? Abstract factory design. Now few things we have to do before we do this. We need to extend the main for all. So now we have to implement this method as main for all is a trait. So as of now, we will just print. In the next video, we are going to implement exactly what the abstract design pattern is. So this is our executing abstract factory design. Let's get back to our main. Now we have this app map. Let's import it. Then .get, we put it here. App name. So now till now we have the app name in place. Now this is an option of options. So we have to sort this out so that we get exactly the app name out of it. So how should we do that? Let's do some pattern match again. So now if we get some app here, it will return an app. If there is something else, then it should throw an exception. And we name it as not a valid app. So this is a message that we will see if it is not a valid app. So now what is the value of app name? Still it is option of class. We need to get out of it. So let's put another get or else throw an exception. No app name provided. So this exception will be thrown if there is a wrong app name. This exception will be thrown if you don't have any app name. This can be controlled on different level with different ways. You can also control it on the command line level, command line parser level, and so there are ways to do it, but we are going with this for the sake of our video. So let's create an app instance which will be our app class dot get constructor declared constructor dot new instance. Now we have this instance. Let's correct the name. Now we have this instance create, so we have this app instance dot run, and we have this options. So now our app is ready. Let's see and run. So option is nothing but what we have passed out of the argument. App instance is nothing but the instance of the abstract factory design, and as we will add more value to this map, we will see this growing. And in future, if you want to add any compliance to this, like you want to pass any logger or anything else, you can add in here, or anything that you want every app to perform, that you can apply from here. So it will pass on to all the apps, and this can be implemented here as an abstract, or you can define inside main as you like it. Let's run this and see how it performs. Alright, we did one mistake. We have not modified the run parameter. Let's take it. So the error message, not a valid app, we have provided a wrong app name. So why it is so? Because here I have given a wrong app name. Let's fix it. Let's run it. So it is executing abstract factory design. So this completes the implementation of the project. In this project, what we have done is we have used multiple design patterns to implement this. You can introduce implicits to pass on values, like if you are using it with Spark, you can pass the session as implicit, you can pass the logger as implicit, and you can pass any other values, like if you are using Akka, you can pass your actor system as an implicit, so that they will have one value or one thread or one tree across entire project. So if you enjoyed this video, please like and subscribe, and see you in the next video where we will be implementing the abstract factory design. Thank you.